Now here's where the word naive comes in naive Bayes. We're going to make a pretty naive assumption here. Let's look at the probability of two events happening together, so P of A and B. We can also write this as P of A intersection B. And we're going to say that this is the product of P of A and P of B. Now, this only happens when the two events are independent. If they're not, then this is not true. For example, if A is the event of it being hot outside and B is the event of it being cold outside, then they both have a positive probability. But now, what's the probability of both events happening at the same time? This would be 0 since it can't be hot and cold at the same time. So this formula doesn't follow because the events of being hot and being cold are dependent on each other. But in naive Bayes, we will assume that our probabilities are independent. This, as we said, is a false and naive assumption, but in practice it works very well and it makes our algorithm very fast. Another formula that we'll use is the formula for conditional probability. These are two ways of writing P of A intersection B, and this is the basis for our Bayes theorem. But the trick we'll use here is to forget about P of B, and now we don't have these being equal, but we have P of A given B to be proportional to P of B given A times P of A. This will work very well because in the practice, P of B will cancel out, so the fact that these two are proportional is very useful. And now here's what we want. We have an email that contains the words easy and money, and we want to know if it is spam. So we want this, the probability of the email being spam given that it contains the words easy and money. We'll start by using our conditional probability rule that we just reviewed to write it as a product of the probability that the email contains the words easy and money given that it is spam times the probability of the email being spam. In this formula, A represents being spam and B represents containing the words easy and money. Now we are ready to use our naive assumption. This first factor over here is a probability of the email containing the words easy and money given that it is spam. We can write it as the probability of the email containing the word easy given that it is spam times the probability of the email containing the word money given that it is spam. Again, huge naive assumption since these may be dependent. It could be that containing the word easy actually makes it more likely that the email contains the word money. But that's okay. In many cases, this assumption won't affect the results and it will make our calculations much easier. And this is the heart of the naive Bayes algorithm. And now we do the same thing for ham emails. We have both probabilities written as a product of factors. But what are these factors? Well, we've calculated them before based on our data. The first one, P of containing the word easy given that it is spam, is 1/3, since there are 3 spam emails and one of them contains the word easy. For P of containing money given spam, that's 2/3, since there are 3 spam emails and 2 of them contain the word money. And P of spam is very simple. It's 3/8 since there are 8 emails and only 3 of them are spam. We do a similar calculation for the bottom one and get 1/5, 1/5, and 5/8. Now we multiply them and we get that the probability of spam, given that it contains the word easy and money, is proportional to 1/12. And for ham, it's proportional to 1/40. Now remember that these values are not the actual probabilities. They are proportional to the actual probabilities. So what do we do to get the actual probabilities? Here's the magic. We know that an email has to be either spam or ham, so these two should add to 1. So we need to normalize them, namely, multiply them both by the same factor so that they're still proportional to 1/12 and 1/40, but they add to 1. Let's try that in a quiz. Can you find two numbers that add to 1 and that they are in the same proportion to each other as 1/12 and 1/40? Enter your answer below.